Okay, guys, another collision demo. In the last video I did, I didn't think the collision demo was good enough, so I thought I'd do another one just to show that what's possible. And I'm going to start by running the improved demo. And we have a small breakout game. This is incomplete, but it shows a lot more of what can be done. Um, so we have a paddle, we can move it left to right, and we have a ball that's just sitting to be activated if we press the space bar, and it can hit the bricks and they disappear. We don't have a score in this one, but we do have a lot of things happening. So the logic of this game, let me run it again because I think that was just a little short. See, sometimes it goes a little wacky and goes too fast. I don't know what that is all about, but maybe it's running things in a DOS box and occasionally screws up. But when it's working normally, it's running at a pretty good speed. And yeah, there's several things happening here. There's collisions happening with the ball and paddle, the ball and the wall, and the ball and the bricks. And each time there's a collision, we handle it differently. So if there's a collision with the left or right wall or the top wall, we just change the direction of the ball. When it hits the paddle, we change the vertical direction of the ball. And depending on how it hit the brick, it goes the opposite direction. So if it hit it from the top, it'll bounce back to the top. If it hit it from the bottom, it'll go towards the bottom, just like breakout plays. And it doesn't do much more than what you're seeing after the last brick is cleared. It really doesn't go anywhere, and this is just because this is a small demo. That's all it is, and the code is pretty small. So I'm going to let this just go through, and it'll finish. Okay. So in the last demo, I showed you how you can use the set shape command that I created with the collision library to set the different shapes that we use. So in this case, I've added some constants so we could identify them easier. So what happens here is we're uh, setting the properties for each shape. So we can have multiple shapes, and for each player or object, we can have one or more than one shape. So in this case, the paddle right now is only made from is only made up of one shape, but we can make it out of two shapes or three shapes, and depending on which shape it hit, we can make it go different directions, and that would be accomplished here in the collision part where we specify which shape hit which and what collision action to take. So all the logic is basically grouped here in the collision settings. Uh, there's three walls that you're not seeing, but basically each time the ball hits a wall, there's an action. And we don't need to do anything except define the procedure that we want to be executed when that collision happens. So when the ball hits the paddle, the ball paddle collision will be triggered and it'll call this procedure. So if we go up here and just, all right, so ball paddle collision. So all we do is just change the direction of which way the ball will go. And the same thing with hitting the walls. We just change the direction where the ball goes. Now we can't see the walls, And that's because right now they're hidden, but they're still active. What I will do is enable so we can see them, and you'll get a better idea how the collisions work this way. So now if we look to the top, left, and right and bottom, we can see the four different walls that we defined. And again, the game works the same way, except we just have the walls. And so you can see now when the ball hits the wall, and I'm not going to keep playing this, but uh, you get the idea. And we also have different draw procedures for each shape. So right now, we're executing the draw paddle and draw ball for these shapes, but we can easily change that. So right here, I'm using a put image command to display an image of the paddle, but I could also draw it with drawing commands. So I'm going to change this to a green paddle. Let's run that and see what happens. So you can see now it's not a bitmap anymore, um, but it works the same way. So let me just, all right, so let's quit. And we can do the same thing with the ball. So instead of drawing a bitmap image, we can use the drawing commands to create. So you can create a full game in a vector type environment if you like. So there's the ball, it's just a square, but again, it works the same way. So the game logic doesn't change at all, the collisions don't change, only the appearance of the shape changes. Okay, quit that. I'm going to put back the way I had it. Okay, just make sure it still runs. Yeah, okay. Now, in my previous code that I released, I did have uh, one thing I did miss, and that was the move player procedure. I added a bit more logic because the way I initially coded it, it was just wrong. It wasn't moving all the shapes properly in the the object. So if you had more than one shape defined for a player, uh, it would move them to the same X coordinates and they would just all bunch up and not look proper. But this change fixes that. And I've also wrote a small VGA unit for mode 13. So it only has these set of procedures here, just a bare minimum to show this demo. This is a little faster than the built-in graph. Um, it can be expanded to do more, but right now all it does is just these three things. It draws a rectangle filled in empty and the put image. I've had to put the disable the range checking because this little thing triggers off the Freepascal compiler to give us a runtime error. This is still legal, but the compiler doesn't know that if things were getting out of range when we specify a value greater than 0, but because this image is can't be defined ahead of time how big it is because the paddle and the ball are different sizes. this is the only way that you can do it. And turning off the range checking allows us to compile this. If we don't, let me just turn the range checking on and you'll see what happens. And save this. And let's run it. And we get a runtime error. So runtime error 201. So if we go back here, range checking off, run it again, and everything works again. So if you come across that, that's what it's doing. Okay. So let's see. Is there anything else? So right here where we add the bricks, I have a little loop. It basically starts at the last shape we added and continues on adding bricks dynamically. And what we can do here is we can even draw the bricks in different colors if we wanted to. And in the draw bricks in here, we can check what ID each brick is and set the color differently. What I can do is basically, yeah, let's try setting the color to whatever the shape ID is. And that should give us a few different colors. Okay, so let's try playing this way. A little fast again. Yeah, I'm not sure what's causing that, but the game plays, fine either way. Either with all the bricks yellow or different colors, it doesn't matter. Okay, I think that's where I'll end this. Play around with the code. I'll put it on GitHub again, and if you find any problems or make any improvements to this, let me know.